Activity 1. First, application of 3D graphics, and the second one, which is role of mathematics in graphics. Under with chapter 1. So, application of 3D graphics. 3D graphics refers to computer generated imagery that portrays objects and scenes in three-dimensional space, allowing for depth perception and realism. It's extensively used in various fields like video games, movies, simulations, architectural visualization, and virtual reality. So, application of 3D graphics enhances our ability to understand, create, and interact with the world around us, driving innovation, improving efficiency, and enriching our lives in numerous ways. So, 3D graphics have a wide range of applications across various countries, which is examples here. Number one, which is entertainment. This includes video games, movies, and animations where 3D graphics bring virtual worlds and characters into life. Second one, which is architecture. Architects use 3D graphics for designing buildings and visualizing spaces before construction begins. Third one, which is product design. Industries like automotive, aerospace, and consumer goods use 3D graphics for prototyping, designing, and simulating products. Simulating and training. Military, aviation, and healthcare sectors employ 3D graphics for simulating scenarios and training purposes. 5, which is virtual reality or VR, and augmented reality, which is AR. 3D graphics are essential for creating immersive VR experiences and enhancing real-world environments with digital overlays in AR applications. Next, which is medical visualization. Surgeons use 3D graphics for preoperative planning, training, and simulating surgical procedures. 7, which is education. 3D graphics enhance learning experiences by providing interactive visualizations and simulation in subjects like science, geography, and history. 8, which is marketing and advertising. Companies utilize 3D graphics for creating visually appealing advertisements, product demonstrations, and promotional materials. 9, which is fashion and retail. 3D graphics are increasingly used in the fashion industry for visual fashion shows, digital prototyping, and online shopping experiences. Last one, which is scientific visualization. Researchers use 3D graphics to visualize complex data sets such as molecular structures, weather patterns, and astronomical phenomena. So these are just few examples, but the application of 3D graphics continue to expand as technology advances. So characteristics of 3D graphics. Here, first one is three-dimensional representation. Unlike 2D graphics, 3D graphics simulate depth, allowing objects to be represented in a three-dimensional space. Second one, which is depth perception. 3D graphics utilize techniques such as perspective and shading to create the illusion of depth, making objects appear closer or farther away. Third one, which is realism. Advanced rendering techniques enable 3D graphics to closely mimic real-world objects and environments, enhancing realism and immersion. Fourth one, which is interactivity. 3D graphics often power interactive experiences, allowing users to manipulate objects, navigate virtual environments, and interact with simulations in real time. Fifth one, which is complexity. 3D graphics can handle complex scenes with intricate details including textures, lighting effects, and animations. Next, which is scalability. 3D graphics can scale from simple geometric shapes to highly detailed models, making them suitable for a wide range of applications from video games to architectural visualization. Rendering techniques. Various rendering techniques such as ray tracing and rasterization are used to generate 3D images from mathematical representations of objects and scenes. Last one, which is hardware requirements, which is rendering high quality 3D graphics often requires powerful hardware, including graphics processing units or GPUs, capable of handling complex calculation and rendering tasks. So, role of mathematics in graphics. Mathematics plays a fundamental role in graphics by providing the framework for representing shapes, transformations, lighting, and more. It it's used to describe geometric objects, calculate positions and orientations, perform transformations like rotations and scaling, and simulate physical phenomena such as light, reflection, and refraction. In essence, mathematics serves as the language that allows computers to create and manipulate visual images with precision and accuracy. So, meaning, a mathematics is used to describe shapes, transformations, lighting, and shading, allowing designers to accurately represent objects and scenes in a digital environment. So, fundamental roles of mathematics in graphics. First one, which is geometry. Geometry provides the foundation for defining shapes, position, and transformations in graphics. Concepts like points, lines, curves, and surfaces are essential for rendering objects in digital space. Second one, which is vectors and matrices. Vectors and matrices are used to represent positions, directions, and transformations in 3D space. They facilitate operations such as translation, rotation, scaling, and projection, crucial for creating realistic. So, calculus. Third one, I should say trigonometry. Trigonometric functions are heavily used in graphics for calculating angles, rotation, and projection. Fourth, calculus. Calculus concepts such as derivatives and integrals are utilized in areas like computer animation and physics simulations. So, fifth line, which is linear algebra. Linear algebra techniques are pervasive in graphics for solving systems of equations, computing interactions, and in performing transformations. Last one, which is numerical methods. Graphics often involve solving complex equations and optimizations for which numerical methods like interpolation, approximation, and numerical integration are indispensable. So next, which is the usage of mathematics in graphics. First one, which is modeling. Mathematics is used to define and manipulate geometric shapes and objects in a virtual 3D space. Equations and algorithms describe the curves, surfaces, and volumes that form the basis of 3D models. Second one, which is transformations. Mathematics enables transformations such as translation, rotation, scaling, and skewing of objects. 3, which is rendering. Mathematical technique simulate the behavior of light and its interaction with surface to produce realistic images. So, fourth, which is animation. Mathematics governs the motion of objects in animations. Equation of motion, dynamics, and kinematics determine how objects move, deform, and interact with each other over time. Texturing, mathematical functions and algorithms are used to apply textures to surfaces, creating details and patterns that enhance realism. Simulation. Simulation, mathematics powers simulations of real-world phenomena in graphics application. Physics simulations, fluid dynamics, cloud simulation, and particle systems use mathematical models to simulate the behavior of natural phenomena and create realistic effects. So last, which is optimization. Mathematics is essential for optimizing graphics, algorithms, and rendering techniques to achieve real-time performance. Techniques such as numerical optimization, approximation, and parallel computing are employed to improve efficiency and speed. So overall, mathematics is the underlying framework that enables the creation, manipulation, and rendering of digital graphics, providing the tools and techniques necessary for artists and developers to bring their creative visions to life in virtual environment. So thank you.